Okay, so let's have a look at question number 3, and we're going to highlight the important parts as we go through. Color blindness is an X-linked recessive trait. So that means the lowercase letter is going to be colorblind and the uppercase is going to be normal vision. If a normal sighted woman whose father was colorblind marries a colorblind man, what is the probability that they will have a son who is colorblind? Okay, so if a normal sighted woman whose father was colorblind marries a colorblind man, what is the probability that they will have a son who is also colorblind? So those are all the important parts. So the first thing that we have to figure out is the genotype of the woman. So let's have a look. So we already know that she's normal sighted. So she has, okay, so use the letter B. So capital B is normal and lowercase b is colorblind. Okay, so we know that she has at least one capital B gene, okay? And so from her parents, we have a male and we have the female. We have the father and we have the mother. So it says, if a normal sighted woman whose father was colorblind. So we know that this is her father because he has the Y chromosome. If the father is colorblind, what that means is that the only X chromosome that he can donate is one that has the colorblind gene, lowercase b. So I'm going to repeat that again. Because the father is colorblind, she has to inherit or be a carrier for the colorblind gene because the father only has one X chromosome that he's able to donate. Now, what about the male? Well, it says marries a colorblind man. Well, he has only one option. This is definitely his genotype because he has to be colorblind, which is recessive. All right, so let's do the Punnett square. Again, I'm going to put, I always tend to put the female at the top, so I'm breaking apart her two gametes, and then the male at the bottom. And take a second, fill it out. Oops. And you should have something that looks like this. So what is the question asking us? It's saying, what is the probability that they will have a son who is colorblind? So let's take my highlighter. I'm only looking at the sons. So I'm looking at this column here, or sorry, this row, because it has to have a Y chromosome. So this right here is the only son that is going to be colorblind. Now, how many sons are possible? 2 out of 4. And so when it says, what is the probability that they will have a son that is colorblind? You're only looking at 2 options. So it's 1 out of 2 or 50% chance of having a color blind son. If it was asking for colorblind child, then you would use the 4, but because it's asking for colorblind son, we are only looking at the two possibilities. So in this case, it's 1 out of 2 or 50% chance of having a color-blind son. Okay, so here's another number 4 that I'm going to let you guys try on your own. And we're going to go to number 6. So let's read it together. Coat color in cats is a codominant trait and is also located on the X chromosome. Cats can be black, yellow, or calico. A calico cat has black and yellow splotches. In order to be calico, the cat must have an allele for the black coat and an allele for the yellow coat. Use a Punnett square to show why there are no male calico cats. Okay, so we have to have 3 different options. We have homozygous for both Y. We have homozygous for both B. And then we have one of both, one of each. So what are these? Well, YY is yellow, BB is black, and YB is calico. Now that's only for females. What about for males? Well, you can have Y and then the male sex chromosome, capital Y, or you can have B and then Y. So this is going to be yellow, and this is going to be black. Did I find a genotype for the calico phenotype in males? No, I didn't. Okay, so because of that, there's no chance that I can have a calico male. And that's because the genotype requires 2 X chromosomes, one to carry the Y allele and one to carry the B allele in order to be calico. So it's asking for 2 Punnett squares. Oops, let me choose a different color. Or sorry, it's asking for Punnett square. So let's take this male, a yellow male, and let's cross it with, what's the chance that we can have a calico? Let's try it with a black female. I'm filling in my Punnett square. Okay, so the only chance that we have for males phenotype is only a yellow male. Let's try a different combination. Let's do a black male with a calico female. If I fill this in, and now I'm going to look at my male genotypes to see the male phenotypes, I see that, guess what? I have a black male here, and then I have a yellow male there. So we can say there is never a chance to have a calico male because it requires 2 X chromosomes to present the calico phenotype. So what does that mean? Present the calico phenotype. Basically, to look like a calico. So again, let me repeat. Because the calico phenotype requires 2 X chromosomes and all males only ever have 1 X chromosome, there is never a possibility to have a calico male. Okay, so try the next few questions and we'll come back to another one that I'll do as an example.